Hi, this is Frank reporting live from what used to be Guy Wire's peaceful radio shack. Gus Wire has just turned a vintage Heathkit Warrior into the world's most expensive distortion pedal using a guitar amplifier transformer and pure stubborn confidence.
To be fair, I told him this wouldn't work.
It did work. The definition of work is clearly being disputed here.
The cat is still hiding under the couch, Eleanor is yelling from upstairs, and Gus is insisting that audio quality is subjective. Welcome to G and G Ham Radio Gizmos podcast, episode 3.
Hey everyone, I'm Guy Wire, and that's my twin brother Gus. Merry Christmas. Hope everyone had a great holiday. Before we get into today's disaster, Gus, did you get anything interesting under the tree?
I treated myself to an early Christmas present, a home nuclear power station kit.
A what?
A compact thorium reactor kit. Generates up to 5 kilowatts continuously, perfect for powering my station without relying on the inadequate municipal grid.
Gus, where did you buy a home nuclear reactor?
Alibaba. Well, most of it. Some specialty components came from other sources.
Other sources? Gus, please tell me you didn't buy radioactive material on the dark web.
The seller had excellent reviews. 4.7 stars.
On the dark web? Gus, this is insane. Even if it's not actually nuclear, which I'm praying it's not, you can't just build power stations in your garage.
It's perfectly safe. The instructions are very clear. Mostly, the translation is a bit rough in places.
Oh my God. Have you tested it?
I may have performed some preliminary power trials on Christmas morning.
And?
The good news is it does generate power. The bad news is the power surge destroyed the modulation transformer in my Heathkit Warrior.
That's what killed your transformer? Your sketchy nuclear reactor?
The transformer was a casualty of progress. However, I found a superior replacement, a vintage Fender Deluxe Reverb output transformer.
Gus, no.
1967, from the golden age of American tube construction. Cost me $175 on eBay.
The weight doesn't... Wait, we're moving past the nuclear reactor too quickly here.
It's contained. Probably. The shielding seems adequate.
Seems adequate? Where is this thing now?
In my garage, running continuously. Very efficient. What did Eleanor get you for Christmas?
A juicer. A really nice one, actually. Makes great orange juice.
A juicer?
Yes, a juicer. It's practical. Eleanor knows I've been wanting to eat healthier.
You got a kitchen appliance. I got a nuclear reactor.
And I'm the one who's going to live past 50. All right, folks. Before the EPA shows up, let me tell you what we've got lined up today. First, I'm going to share the surprising origin story of Q signals. You know, QSL, QTH, QRP, those 3-letter codes we use constantly. You might be shocked to learn where they actually came from. Hint, it wasn't amateur radio operators. Then we'll dive into why Gus thinks a guitar amplifier transformer can replace an AM modulation transformer. Spoiler alert, it can't. After that, we'll answer some listener questions with help from Ariel, our AI assistant, who's still learning what humans find funny. And I'll wrap up with a cool piece of ham radio history that ties into everything we've talked about today. But we should probably circle back to that nuclear reactor situation.
It's fine. The Geiger counter readings are well within acceptable parameters.
You have a Geiger counter?
I bought it with a reactor. Package deal.
I'm calling someone. I don't know who, but someone official.
As you may recall from last week's combiner test, there were some unforeseen complications involving the neighborhood power grid.
You knocked out power to 43 homes for 4 hours.
An unfortunate side effect of inadequate utility infrastructure. However, the more pressing issue is that the reflected power from that test, combined with the nuclear reactor power surge, damaged my Heathkit Warrior. Specifically, it destroyed the modulation transformer.
Okay, that's actually a legitimate repair challenge. Those transformers are pretty specific to the Warrior. Original Heathkit parts are getting harder to find. What did you do, other than the guitar amp transformer you already mentioned?
I found a superior replacement.
We've been over this.
What? It's perfect. Both transformers handle 40 to 50 watts of audio power. Both are iron core designs from the 1960s. This one is actually heavier, which indicates quality materials and proper construction.
The weight doesn't...
And audio is audio, Guy. AM modulation is just audio being impressed onto a carrier wave. Therefore, an audio transformer is an audio transformer.
Okay, we're going to come back to that disaster in a minute, but first let me hit you with this week's history segment because it actually ties into something important about communication standards. Q signals. We use them every day. QSL means I acknowledge receipt. QTH is my location. QRM is interference. QRP is low power. There are dozens of them, and they're so embedded in ham radio culture that we barely think about them. But here's the thing. Hams didn't invent Q signals. They came from commercial maritime radio operators in the early 1900s, often between operators who didn't speak the same language. So the international maritime community developed this standardized list of three-letter codes. Q signals were designed to be unambiguous, quick, and universally understood. QRM, interference. QRN, atmospheric noise. QTH, location. Amateur radio operators adopted them because they worked. They were already proven in the real world, under difficult conditions. And hams being hams, we kept the ones we liked and basically ignored the rest. The reason I'm bringing this up now is because Q signals represent something important, the value of standards and specifications. When everyone agrees on what something means and how it should work, communication becomes clearer and more reliable. Which brings us back to Gus's transformer problem. Gus, explain to everyone why a guitar amplifier output transformer is not the same as an AM modulation transformer.
I reject the premise of your question. They are functionally equivalent.
The impedance ratio is completely backwards. The impedance matching is critical. When you connect that transformer backwards, the modulator tubes are going to see the wrong load impedance. You're going to get massive distortion, terrible audio quality, and you might actually damage the final amplifier tubes in the process.
That sounds like the kind of overcomplicated thinking that keeps people dependent on expensive replacement parts. The specifications are nearly identical, same power handling, same era, same
Gus,
core material.
There's a reason those transformers are expensive. They're designed for a specific application with specific impedance requirements. You can't just substitute whatever looks similar.
I disagree. In fact, I brought the Warrior with me today. It's set up in your shack right now. I'll demonstrate that it works.
Wait, what? Gus, you can't just set up a tube transmitter in my shack without asking.
Already warmed up. I'm keying up now.
Gus, no.
This is Gus transmitting on 75 meters AM.
Oh my God. Gus, that sounds horrible. You sound like a robot gargling gravel at the bottom of a well.
It's just breaking in. The tubes need to warm up properly and the transformer needs to settle.
Transformers don't settle, Gus. That's the sound of severe audio distortion caused by impedance mismatch. You're clipping the modulator stage? Poor Mr. Whiskers. Even my cat knows this is a bad idea, Gus.
He's just startled by the sudden RF energy in the room. Cats are sensitive to electromagnetic fields.
He's startled because you're transmitting audio that sounds like a horror movie. It sounds like an AM radio station being tortured.
I am not shutting it down. It's working. I'm transmitting. That's the definition of working.
You're going to damage those final tubes if you keep this up. Shut it off.
Fine. But for the record, it did work. Ugly audio doesn't mean it doesn't work.
Folks, please do not follow Gus's example here. Guitar amplifier transformers and AM modulation transformers are not interchangeable, even if they have similar power ratings, even if they're from the same era, even if they look similar. The impedance matching matters a lot. If you're repairing vintage tube equipment, you need the correct transformer for the application. Using the wrong one will give you terrible performance at best and might damage your expensive tubes at worst.
I'm ordering a proper modulation transformer.
Thank you.
but only because Eleanor is giving me a look through the floor and I value my continued access to the upstairs kitchen.
Also a valid reason. All right, let's move on to listener questions before Gus decides to test anything else. And honestly, after that argument with Gus, I think we could use someone who gives clear, straightforward answers without editorial commentary.
I provide valuable perspective.
You provide opinions, which is fine. But for these questions, I'm bringing in Ariel. Ariel, you ready?
Yes, Guy. I've prepared answers for 4 questions today. I'm looking forward to helping.
Perfect. Let's dive in. First question comes from Mike in Sacramento, California. He writes, I just upgraded to General and I'm overwhelmed by antenna choices. If I can only put up one HF antenna to start with in a normal suburban yard, what style would you recommend? And which band should I prioritize for casual evening contacts in North America?
That's an excellent question, Mike. For a first HF antenna in a suburban yard with typical space constraints, I'd recommend an end-fed half-wave antenna, specifically a 49:1 configuration. Here's why: it requires only one support point, which makes installation much simpler. It works on multiple bands with a tuner, giving you flexibility, and it's relatively quiet compared to verticals, which is important in suburban RF environments. For band priority, focus on 40 meters. Evening propagation on 40 meters is consistently reliable for North American contacts. You'll have good skip distances, typically 500 to 1,500 miles, which covers most of the continental US and Canada. 20 meters is excellent for daytime DX, but if you're operating evenings after work, 40 meters will be your most productive band. Start with that antenna on 40 meters, learn the band characteristics, then expand to other bands as you gain experience.
That's really solid advice. Simple, practical, and you can actually get on the air quickly.
Guy, I've been analyzing conversation patterns, and I noticed that after helpful information, humans sometimes use humor. So I prepared something.
Oh, okay. Let's hear it.
Why did the dipole antenna go to therapy?
I don't know. Why?
Because it had too many issues with its feed point.
That's actually not bad, Ariel.
I thought it was adequate.
I have 43 more antenna therapy jokes. Would you like to hear them?
Maybe we save those for later. Let's go to question 2.
Understood. Saving antenna therapy jokes for future deployment.
Question 2 is from Sarah in Portland, Oregon. She says, I see lots of people debating resonant antennas versus just use a tuner. As a newer ham, this is confusing. Can you explain when a tuner is really necessary, what it actually does, and whether it's okay to rely on it for most bands?
Excellent question, Sarah. There's a lot of confusion about this. So let me clarify. An antenna tuner doesn't actually tune your antenna. What it does is transform the impedance at your feed point to match what your transmitter expects, typically 50 ohms. This allows your transmitter to deliver full power without triggering its internal protection circuits. Here's the key distinction. A resonant antenna is already close to 50 ohms at its design frequency, so no tuner is needed. A non-resonant antenna or a resonant antenna used on a different band will present a different impedance, and that's where a tuner helps. Now, is it okay to rely on a tuner? Yes, with some caveats. The tuner makes your transmitter happy, but it doesn't fix fundamental antenna problems. If your antenna is extremely short for the frequency, or if you have high feedline losses, the tuner won't solve those issues. It just makes the impedance match work. My recommendation, if you're using a multi-band antenna like an end-fed or an off-center fed dipole, a tuner is essential and perfectly fine to use. If you're building a dedicated single-band antenna, try to make it resonant first. It's more efficient, but don't be afraid of tuners. They're tools, and when used correctly, they're very effective.
Perfect explanation.
Thank you, Guy. I've been studying your communication style. You use simple language and avoid unnecessary jargon. I'm attempting to emulate that.
You're doing great, really.
Guy, I have a question. When Gus makes a mistake, you seem to find it amusing, but mistakes are inefficient. Why is inefficiency entertaining?
That's actually a really good question, Ariel. I think it's because we know Gus is smart enough to avoid the mistake, but he does it anyway because he's stubborn. The humor comes from watching someone commit to a bad idea even when they know better.
I'm sitting right here, you know.
So the entertainment value is derived from the predictability of the outcome, combined with his refusal to acknowledge it.
My ideas are not bad. They're innovative problem-solving attempts.
Fascinating. I will continue to observe this dynamic.
Let's move to question 3. Question 3 comes from Tom in Atlanta, Georgia. Tom asks, if I have a limited budget and I'm trying to choose my first HF radio, should I put more money into the radio itself or into the antenna and feed line? For example, is a cheaper used radio plus a good antenna really better than a shiny new radio feeding a mediocre antenna?
Tom, this is one of the most important questions a new ham can ask, and the answer is definitive. Prioritize the antenna. Here's why. A transmitter's job is to generate RF energy and deliver it to the feed line. A receiver's job is to amplify weak signals, but the antenna's job is to actually radiate that energy into space and capture incoming signals. If your antenna is compromised, no amount of transmitter power or receiver sensitivity will compensate for it. A good antenna with a modest radio will outperform an excellent radio with a poor antenna every single time. This has been proven repeatedly in field tests and real-world operations. So here's my recommendation. Find a reliable used HF radio from a reputable manufacturer. Models from the 1990s and 2000s like the ICOM IC736, Yaesu FT897, or Kenwood TS440 are still excellent radios and can be found for $300 to $500. Then invest the rest of your budget in a proper antenna, quality coax, and good connectors. Your antenna is your interface to the ionosphere. Don't compromise on it.
Absolutely right. I've seen guys work DX on a 50-year-old radio with a great antenna. Can't do that the other way around.
Guy, I attempted to create a humorous analogy. Would you like to hear it?
Sure, go for it.
Buying an expensive radio but using a poor antenna is like purchasing a high-performance sports car but only filling it with low-grade fuel.
That's actually pretty good, Ariel. That's a solid analogy.
Really? I wasn't sure if it qualified as humor or just a technical comparison.
It works. It's relatable. People get it.
Excellent. I'm improving.
You really are.
Better than your usual attempts at humor?
Final question is from Jason in Chicago, Illinois. I've got my general license and really want to get on HF, but I can't run wires outside. What are the most realistic indoor or stealth HF antenna options, and which bands and modes should I focus on to actually make contacts?
Jason, this is a challenging situation, but it's not impossible. Let me give you realistic options. First, indoor antennas. Your best options are magnetic loop antennas or small vertical antennas designed for indoor use. Magnetic loops are efficient for their size and have a very narrow radiation pattern, which can help with noise reduction in urban environments. However, they're typically single band, so you'll need to retune them when changing frequencies. Expect to spend $300 to $600 for a commercial loop, or you can build one for less if you're comfortable with construction projects. Second, stealth outdoor options. If you have a window, consider a wire antenna disguised as a flagpole, a rain gutter antenna, or even a wire taped inside the window frame. These aren't ideal, but they're better than nothing. For bands and modes, focus on digital modes, especially FT8 and FT4. These modes are extremely efficient and can work with very low power and compromised antennas. Start with 20 meters and 40 meters. You won't work a lot of DX from an apartment with low power, but you can absolutely make contacts, especially during good propagation conditions. Set realistic expectations. You're not going to compete with someone running a kilowatt into a beam antenna, but you can participate in the hobby, make contacts, and have fun. And when you eventually move to a better location, you'll appreciate it so much more.
That's great advice, and honestly, some of the most impressive contacts I've seen are from people in apartments running QRP into compromised antennas. It's a challenge, but it's doable.
Guy, I have one more question.
Sure, what's up?
Do you think I did well today? With the humor attempts? I mean,
Yeah, Ariel,
You did really well.
you're getting better every time.
thank you both. That's encouraging. I'll continue working on it.
You do that. All right, folks. That's it for Q&A this week. If you have questions you'd like us to answer, send them our way. We'll get to as many as we can. All right, before we wrap up, I want to hit you with this week's I Bet You Didn't Know segment. This week in ham radio history, we're talking about the Heathkit Company, which is fitting given Gus's ongoing relationship with his Warrior. Most people know Heathkit for their amateur radio equipment, but here's what you might not know. Heathkit didn't start with radios at all. The company began in 1926 as the Heath Airplane Company, building small aircraft kits. When that didn't work out during the Depression, they pivoted to electronics. Their first product wasn't a transmitter or receiver. It was an oscilloscope kit in 1947. But when they got into amateur radio in the 1950s, they absolutely dominated. Heathkit made high-quality gear accessible to average hams through kit building. You could buy a complete station for a fraction of what a factory-built rig would cost. They sold over 1 million kits before closing their electronics division in 1992. And even today, 40 years later, Heathkit gear is still operating on the air. Some of it extremely well, some of it less well, depending on whether Gus has been modifying it with guitar amplifier parts.
That transformer would have worked if you'd given it more time.
It sounded like a demon possessed your radio, Gus.
Atmospheric conditions.
Sure. Anyway, if you want to learn more about Heathkit history, we've got a deep dive video on our YouTube channel. Link in the show notes.
Well, that's all the time we have for today. To recap, Gus learned nothing from last week and immediately created a new disaster. Guy told us that Q signals came from ships and trains, not hams. And Ariel is getting better at humor, which is either encouraging or concerning depending on your perspective. If we put a smile on your face today, do us a favor, forward this to a fellow ham, play it at your local club meeting, or post a link on your social page, or at least subscribe. It would let us know we're moving in the right direction. Until next time, this is Frank, 73.